$100 at the end of the second year, $200, $300, $400, $500, and $600. And I want to know what A is. And you do that exactly like you did everything else. You want to change a gradient into an annual amount, or given G, find A, or as the reference manual uses it, 2A given G, that's the way our book uses it, 2A given G. Then I would use the A over G column, the I percent, the N years. The gradient that I told him I will be able to pay back is $100. So I use the A over G column, 6% interest, 7-year row. Go and book, you find the numbers 2.7676, and that means that he will allow me to withdraw from his bank $276.76, and then I will start paying it back the second year. I'll have to give him $100, then $200, then $300, and so on. The reverse of that, no, that's not the reverse, this is a different one. Like I say, these are coming in the order that they are listed in the reference manual. Find the present value given, well, this is a different one here, given A and G. The reference manual doesn't give you any A and G. He expects you to be able to take A and get its present, and then find G and get its present value. How much money would you have to put in the bank today, right now, instantly, to be able to draw out $200 at the end of the first year, $230 at the end of the second year, and $260 at the end of the next year, and so on? So here are our annuities. You'd like to withdraw $200, then you'd like to withdraw $230, then you'd like to withdraw $260, and so on. And finally, at the end of the 7th year, you'd like to be able to withdraw $380. Straight line. Now, what you can do is you just say, well, the amount necessary is a P1 and a P2, where P1 is the amount of money I need to fund the annuity, and P2 is the amount that I would need to fund the gradient. So, P1 is A times P over A. That changes the annuity into the present value. P2 is G, the known gradient, times P over G. The annuity is $200 every year. The gradient is 30, 60, 90, 120 for 7 years. Fortunately, this problem appeared in standard form, or it was easy to make it into standard form, because you just go to the first value and scrape off the top, and you make the bottom half an annuity, and you make the top half a gradient. So you should always be able to do that. The only time that they might mess you up is if they moved, if they said, and I want to withdraw $200 today, moving this whole thing over to the left one slot, well then you'd have to work around that. You'd have to get it into standard form. Alright, then if you'll check the factors, you'll find that the factor needed to change an annuity into a present value would be 5.5824. To change a gradient into a present value is 15.4497, and you simply add them up. And that also should demonstrate why the gradient starts on the second year, because that really makes this kind of operation easy without moving that gradient around someplace else. Now, what if we were able to invest $600 today? Whoa, that's not standard. $550 at the end of the next year, $500 at the end of the next year, and so on until we actually put in $250 at the end of year 7. How much money could we take out of the bank at 6%. Well, in that case, you have to do a little work with it. What you do is you pretend that you put in $600 every year. And then you extract from that a gradient. Now you'll notice that the problem statement says we're going to go from year 0 to year 7. But you're not permitted to put the first value of an annuity in the 0 year. And therefore, what you're going to have to do is you're going to have to move time back a slot. See how I moved the 0 back to here, and went to standard form and said, you didn't put the annuity in now. You thought about it a year ago and put the first annuity number in a year after that, which just happens to be now. That means this goes to the 8th year. Same way with the annuity. What we're doing is this piece right here, this reduction, we pretend we're putting money into the bank there, and we're taking money out of the bank here to make up for the fact that these cash flows go down with respect to time. Therefore, the first part of the future value, this is F is equal to F1 plus F2. The first part is the annuity part. Note the 8 years. Get the factor, $5,900. The second part is a gradient, 8 years. Phooey, he doesn't have F over G, so I had to go find F over A for 8 years and then A over G for 8 years. The A canceled the A, leaving me with F over G, which is what I need. And that's equal to $50 times the two factors found from the table for the 8 years. Gave me $1,581 for the second part. This, of course, is a negative number because it is been extracted from the bank. Therefore, the future value is $4,357. The sum of the two, I guess this really should say, either should say minus here, or that ought to be negative, in which case the plus sign is okay. All right, now then, let's see what happens if these payments are not compounded annually. What if I tell you I'm going to use an interest rate of 6%? I mean, it's not really 6%, but it's a nominal rate of 6%. And I tell you what, if you'll bring your $6,000 to my bank, I'll compound your interest every quarter. In other words, every 3 months, rather than only compounding it at the end of the year. Now, the advantage to you in this is that I'm willing to pay you, not really 6% a year, but I'm really willing to pay you 1.5% interest on your money every 3 months. It means you're going to get more interest on your money because you're going to be getting some interest on interest before the end of the year. For example, here's what I'll do. You bring your $6,000 to me today, and at the end of 3 months, I'll give you $6,000 times 0.015, a fourth of the nominal interest rate.